All right, we're going to go over the reverse engineering portion of the Unit 6. So today's PowerPoint is going to cover what reverse engineering is and give you guys a little bit of insight. At the end of this, you'll fill out a Google form. It's 2 questions, and it covers the information in the PowerPoint. So my suggestion is to make sure you watch the video. You will be graded on watching the video through Edpuzzle, and then also taking the short quiz. Okay, so let's get started. So the definition of reverse engineering is for you or someone else to take something apart, analyze how it works in detail, and the purpose is to understand its structure, its function, and its operation. You have a picture of a mechanical watch on the right-hand side. So that's the purpose behind it. There's a little bit more to it than that, though. Engineers do it because they may want to create some documentation that doesn't exist. They might want to discover something new, might want to investigate it, or improve something. So the documentation, the issue mainly is that nothing might exist. And in the case of documentation, it's done so that in the future, other engineers will be able to access that documentation. So taking something apart and looking at it can give engineers an idea of how it works or what it's doing, and then they can create the documentation for that. Also, if no documentation exists, it also helps if it's something that has to be maintained so that it continues to work. So there are those reasons for documentation. In discovery, we're specifically talking about discovering new things, and that might come in the form of academic research or just a curiosity of how what something would how something would work, and in doing so, the discovery of something. So you see the reverse engineering of the human brain. It's something strange to think about, but it's reality because there are scientists that do that kind of thing, that have figured out a lot about how our brains work. Same thing with Genome Project on the right-hand side. Again, it's a reverse engineering process. It's starting with something larger and breaking it down into much smaller pieces. And the reality is that a lot of times you discover things, new things that no one knew about. So that's another reason. In addition to that, it can also help to discover and create new military and commercial intelligence. And the reason that they separate that is because it's a totally different sector from other things that people think about. But having the latest and greatest, the cutting edge stuff requires discovery so that you can create it. Investigation. So I'll talk about the pictures below in a minute. It happened a while ago. But here's the situation. When reverse engineering is performed for investigation, we're trying to find out what happened, or how something works, or how it worked, or what happened in terms of its failure. Typically, I would have you guys watch a video in class of a thruway bridge that collapsed when I was a really little kid. I don't remember it. But it collapsed in 87. I don't remember. I was a little kid. But the bridge collapsed because of some things that were done incorrectly. And engineers had to go back to that thruway bridge and figure out and kind of reverse engineer the damage that was there, not to put the bridge back up, but to figure out why it failed. So investigation was done to figure out why the design failed. And that's forensics. So oftentimes people that enjoy that kind of stuff will get jobs where they do an analysis where they're looking at things that unfortunately failed. It killed a few people. Basically the whole eastbound side of the thruway collapsed, and I think then the westbound side collapsed into the Schoharie Creek. You can look it up if you want to. there is a very short video of the Thruway Bridge collapse. I think it was 87. What you're looking at down below is something from the Hyatt Regency Hotel. And what it was actually walkways. And if you look up here, you can see where the walkway was suspended. It was actually a suspended walkway. And then above it, where you can't see anything, is a third floor with another walkway. And what happened is the walkway on the very top came down onto the second walkway. And then the second and third walkways came down onto the ground here. Now, the tragic thing about this is that this was during a party, and so this room was filled with people. Some people were crushed and killed immediately by what happened. Other people were pinned under there, and there are videos of this incident as well, this design failure as well. What you see on the right-hand side is the reason it failed. This is a box beam right here. And then this is the rod in which the walkways were suspended. And what happened is the box beam, as you can see here in the cross section, it's folded up. It's not supposed to be. It's actually supposed to be across here. So if I'll draw a line real quick to show you where the metal is supposed to be located. It's supposed to be located in this area. So what happened is, if you look up here, you can see threaded rod. And so basically what they did was they attached some nuts to the threaded rod and expected that this welded box beam was going to hold. Sadly, it did not. And what happened is the nut basically pushed through the metal, and that allowed the system to collapse down on itself. You would never know that if you didn't do the investigation, though. So unfortunately, for some people, their jobs are to go onto scenes like this where people most likely died and try to figure out what happened. So it doesn't happen again. The last reason you do this is to improve or redesign a product. Things like efficiency, better fuel efficiency in a car, reliability, it'll last longer. Trying to make it so it doesn't fail, reduce the cost to the company, and hopefully they can reduce the cost to the consumer a little bit. Maybe the ease of use is an issue. So there are other things there. I'm not going to go through them all, but this is why. It's to improve. So when you're looking at this is the main idea. When it's a redesign, it's for improvement. A couple of tools. There are many more. You guys see the digital dial caliper in the middle. They've got an optical probe, a 3D handheld laser scanner. Not something that anybody can just plop down money for. Kind of cool though. Micrometers and medical imaging too. Believe it or not, when they're trying to diagnose stuff in animals and people, living organisms, medical imaging can help reverse engineer and see what's going on. Here's the stages. So there's 3 stages: the visual analysis, the functional analysis, and the structural analysis. And each one has their place, and they kind of go in order. So the first one would be the functional analysis, and it's the easiest one to perform. And one thing I kind of want to point out here with this particular analysis is it's non-destructive. So you're basically taking the product and trying to make observations to determine how the product functions. So these observations are recorded in as much detail as possible. What you do with that is you use the principles and elements that you guys have learned to write about and make those observations. The last thing you're going to do is you're going to talk about system input and output. What you know, excuse me, that goes into it, and what you know is coming out. Okay? So let's look at the toothbrush. We looked at the toothbrush back in September. We did look at a PowerPoint where they talked about the history of the toothbrush and some important things that happens. But they write about the purpose first. They kind of define the purpose behind the toothbrush. So it's to clean the teeth and gums. And the purpose behind cleaning all that area is to prevent tooth and gum decay. And some people are more susceptible to that than others. I have not ever had a cavity. I don't know that I ever would. But I have a condition where I have what's too much fluoride. And so my teeth have the ability to not really decay. And it's kind of nice, actually. Water and cleansing paste are used in conjunction with the brush. So toothpaste or gel is, something you're going to get out of that. There's also powders, believe it or not. There are powders you can use as well. I don't know how nice that would be, but certainly those are designed to cleanse, and then you have water to rinse, because you should not be swallowing toothpaste. It is not good for you to swallow it, but it is good to help clean teeth and gums. So let's look at this functional analysis. This is it. This is what you see here. Certainly you can do a sketch if you're a good artist, but my recommendation to students when they would have done a project like this is that you wouldn't want to do a sketch if you can secure a picture, because a picture is as easy to label as a sketch. And it takes less time. And so when we would do the functional analysis in class, I was always asking students to do a picture of what they were going to perform the analysis on. But here's what it is. It's an annotated sketch. So basically they did the sketch and then they labeled it. That's what annotation stands for. So if you look on the right-hand side, you can see that they write about the head with the bristles and the rotation. There's a neck that's secured to it. They know that if they look inside of this device, that there's electricity being converted somehow, okay, into torque. They call it torque. So some kind of twisting motion. There's a housing for the components. Again, we're not sure what's inside. There's a grip there. There's a electrical indicator for the toggling of the electricity. And we know that the device can store electricity. And that's basically it. A functional analysis does not have to be overly complex, but it should make note of specific things that we know are part of the object in question. It says a hypothesis is devised to describe in detail the sequential operation or function of the device. They use a sketch as a reference. So it stores electricity, converts it to torque, and it comes through the head of the brush. Here's the other thing that comes into play in this portion of the analysis is something called a black box. And a black box model is used to identify what goes into and out of the product in order to make it work as a system. So if we back up for a second, this is a miniature system. Okay, it has inputs, it has outputs, and that's what makes it a system. This is what it represents, though. Okay, it represents the product's internal components. Let's highlight that. Represents the product's internal components or processes. And here's the situation. They are deemed unknown at this time. So we don't know what's going on inside there. We can't really say that because we have not taken it apart. We are simply doing a functional analysis at that point. So that's what the black box represents. So here's the analysis. This is what it would look like if we did more of a visual with a simplified system setup. Basically, we look at our inputs of hand motion. That's on your part. There's some toothpaste as an input. There's water. And then there's some energy. Energy that is basically from you and the toothbrush. Remember, toothbrush is using electricity to convert that torque that they talked about into some motion in the bristle heads there. And then you yourself are expending energy to utilize a toothbrush. On the output side of things, we have sound. It's going to make some kind of sound. It's electric motor. Heat, yeah, maybe a little bit of heat. I know when, electrical energy is generated and utilized, it can make some heat. There's going to be waste. So that's the foamy stuff that builds up in your mouth that you're going to spit out because you're not supposed to eat toothpaste. I like to mention that. And then at the end, the other and final output and the object of this whole idea is that you're going to have clean teeth and gums. Again, the black box is representing the unknown of what's going on inside the toothbrush. We don't know for sure. We can't see it. So there you guys have it. Very simple, very basic idea of what a functional analysis is. And again, normally when I have students do an activity like this, I have you guys just do an analysis of a picture of some kind of product. But you can see how this gets the process started in investigating something in the reverse engineering process itself. So hopefully this helps. Now what you're going to do is, once you're finished with the video, I want you to go ahead and go to the Google form and answer the 2 multiple choice questions. And that will let me know that you did watch the video enough to get the information out that was important. Remember, the video is an Edpuzzle assignment, so you will also be graded on watching the video in its entirety to get full credit. All right. See you guys soon.